Hi everyone. Okay, let's talk about linear factors of a polynomial function. So I would like for you guys to graph the following equations on the same graph. We have f of x equals x plus 2 squared times x minus 1, and g of x equals negative x plus 2 squared times x minus 1. And I want you to describe the similarities and differences that you see. So you can either use your own graphing calculator, you can use the classroom graphing calculator, or you can always get online with Desmos and use Desmos. This is what I want you to notice. So I'm going to go ahead and sketch this out on my own paper. Trust me, I have done this with my graphing calculator already to ensure that we have the right values. But our first function, f of x, this one right here, has an x-intercept at -2 and an x-intercept at +1. And you probably could have guessed that based on looking at these factors right here. It's going to look something like that. And then our second function, g of x, also has x-intercepts at +2 and -1. I said that backwards, I'm sorry. -2 and +1. But it looks a little bit different. It looks something like this. So we can tell by having the same factors that our graphs have the same x-intercepts, but our end behaviors are different. It looks like our graph was reflected across the x-axis. So what made that happen? If you look at this negative symbol out in front, we can tell our graph was reflected across the x-axis. The x-axis. But because our factors were the same, because those factors were the same, we know our x values are the same. We know our x-intercepts are the same. X-intercepts are the same. And one more thing, if you look at your end behaviors, you can tell that your end behaviors are going in the opposite direction. As x goes to -infinity, my g of x is going up forever to +infinity, and my f of x is going down forever to -infinity. So we can tell that our end behaviors are opposite because of that negative. End behaviors are opposite. Okay? So let's look at another pair of graphs. We have right here f of x equals x plus 2 times x minus 1 squared, and g of x is equal to x plus 2 squared times x minus 1. We're going to describe the similarities and differences that we see this time in our two graphs. And again, you can use Desmos, you can use a graphing calculator, whatever it is you want to use. I know that I have x-intercepts at -2 and +1. So if I graph f of x right here, I have an x-intercept at -2 and +1. So what does that graph look like? Well, it's going to go something like this. And we're just going to pretend like I can draw well, but this is what our sketch is going to look like. Okay? Now, if we graph g of x, we also have x-intercepts at -2 and +1, but look at the difference that happens. In this instance, our graph, okay, I know it looks like I have a shaky hand. It's just hard to draw on this thing. Our graph looks like this instead. So what made that happen? If you look at the first zero over here at -2, you can see that our f of x, the blue graph, crosses through your x-axis, but your pink graph, g of x, is actually only touching your x-axis. So what makes that happen? I'm going to type because it's easier to type on this thing than it is to write with my finger. So the first thing I want you to recognize is that your x-intercepts are the same. But when we have a factor that has an even degree or an even exponent, your graph is only going to touch the x-axis. Okay, so when we have a factor that has an even degree, like x minus 1 squared, or to the fourth, or to the sixth power, any of those even numbers, the graph is only going to touch the x-axis at that x-intercept. Okay, so what do you think is going to happen when a factor has an odd degree? So an odd degree, for example, to the first power, x plus 2 to the first power, or x plus 2 cubed, or to the fifth power, any of those odd degrees means the graph crosses the x-axis. Okay? So those are the rules that you kind of need to keep in the front of your brain, remember. So can you predict what the graph of f of x equals x plus 3 squared times x minus 1 times x minus 2 is going to look like? Okay, so I'm going to go ahead and list out the factors that we see. I see an x plus 3 to the second power. So I know I have an x-intercept at x equals negative 3. Remember, the sign always flips. So x equals negative 3 is my first x-intercept that I see. It is degree is even. It has an even degree. So what does that tell us? An even degree tells us that the graph only touches at x equals 3. All right, that's one of them that we have. What's another x-intercept that we have? If I look, I see I have a factor of x minus 1, which tells me I have an x-intercept at positive 1. But that is to the first power. That x minus 1 is only to the first power. It's an understood kind of invisible one right there. So that is an odd degree. And what happens to our graph when we have an odd degree? It actually crosses our x-axis. And then I look at this last factor that I have right here, x minus 2. X minus 2 is being taken to the first power as well. So that's another odd degree. So I know my graph is also crossing right here at x equals 2. So I'm going to go ahead and set up my xy coordinate plane. And I know that I have an x-intercept at negative 3, and I know I have an x-intercept at positive 1 and positive 2. So I'm going to plot those 3 points. X equals positive 2 and x equals positive 1. Now there's something else that I want to talk to you guys about that we touched on at the beginning of Unit 6 when we first started studying polynomials. Our first factor is x plus 3 squared. So if we were to multiply that out, our highest degree would be an x squared term. Actually, let me use pink so they match. And then I would multiply that by x minus 1. So I have another variable, x to the first. And then I would multiply that value by x to the first again. So what does x squared times x give us? That's x to the fourth power. And because our exponent, our degree of our polynomial function is 4, that's an even degree. That means our end behaviors, if you remember, go in the same direction. So if the degree of the overall polynomial is even, the end behaviors go in the same direction. And because there's no negative out in front of this polynomial, our leading coefficient would be positive. Both ends of our graph are going to be pointing up. All right, so our degree is even, so they're going in the same direction. Do they go up or do they both go down? They're both going to go up because we have a positive leading coefficient. So I'm going to sketch this graph without looking at my calculator at all. I know if I'm on the far left side, I need to start up, and then I'm going to swing down to my first x-intercept right there at negative 3. But I know my graph is only going to touch at x equals negative 3. So I'm going to go down, and then I have to bounce back up. But then I know I have to go down through an x-intercept at positive 1, but it crosses my graph at or my x-axis, at positive 1. And then I need to go back up so that I can cross this x-intercept again at positive 2. And then I'm finished. My ends are both pointing up. I've graphed all 3 x-intercepts. The first one only touches at -3 and crosses at positive 1 and positive 2. All right, if you flip your note sheet over and you're looking at the back of this note sheet, I want you to try and match these graphs without a calculator first, and then of course check your answers. We always want to check our answers. So you can start with any one of these functions that you want. So if you look at answer choice A, I see that I have an x-intercept at x equals -3. So as a factor, that would be x plus 3. And my graph is actually crossing my x-axis there, so I know it's going to be an odd exponent. And if I look at all of my answer choices, I see my only exponents are either 1s or 2s, right? The invisible 1 or a 2. So I know that's got to be x, that's to the first power. The second x-intercept that I see is here at -2. So as a factor, we would write that as x plus 2. And it is also crossing our x-axis, so that's going to be an odd exponent to the first power. And then our last x-intercept is here at positive 1. So as a factor, it's going to be x minus 1. And again, it also crosses my x-axis, so that's also an odd exponent. So I'm looking at this graph, and I see that I have 3 factors, x plus 3, x plus 2, and x minus 1. So I come up here and I look at my answer choices, and I notice that both this function right here has all of the x-intercepts, all of the factors that I need, and this one right here has all of the factors that I need. The only difference is this negative right there out in front. So which of these equations matches my graph? Well, I'll show you a little trick. If you look at your 2 end behaviors on graph A, I'm just going to kind of connect them with a line. Okay, so I've connected my end behaviors. If that were if that's a linear function, my graph is decreasing as I move from left to right. So I need a negative leading coefficient. So I know that graph A goes with this function. Okay? If I look at graph B, I have an x-intercept right here at x equals -1. So as a factor, I would write that as x plus 1. But this is a little bit different because this time my x-intercept only touches my x-axis, or my graph touches the x-axis right there. So I need an even exponent. And then I have another x-intercept right here at x equals 2. So that's going to be a factor of x minus 2. And because it crosses, it's an odd exponent. And then I have a x-intercept right here at positive 3. So x minus 3 is our factor, and it's crossing again, so I need an odd exponent. So we'll take it to the first power. So I have 2 answer choices that are x plus 1, x minus 2, and x minus 3. That's this one right here and this one right here. The only difference, again, is that we have a negative leading coefficient in our second equation, and our first equation has a positive leading coefficient. So which one should we use? So if I look at this graph and I notice that both of my end behaviors are pointing in the same direction, that's because I have an x squared times an x times an x. Again, that's x to the 4th power, meaning because that degree is even, my end behaviors go in the same direction. Now they're both pointing down. So do you think that means we have an even? Do you think that means we have a negative leading coefficient or a positive leading coefficient? Well, that would be a positive leading coefficient. Okay? Hopefully all of that makes sense to you. I love polynomial functions. They're so much fun. And look at all that we could do without a graphing calculator. You don't need a graphing calculator, but it's, of course, very handy to always check your work. You always want to check your work if you have that capability.